At some point, every woodworker is confronted with the argument that old tools, particularly chisels, are superior to new ones. Some will search antique shops and estate sales and internet auctions looking for these antique treasures, particularly those made in Sheffield, England, which at one time was known for the highest quality of tool steel. And they'll often pay more for an antique chisel than they might pay for a good new one. So is that true? Are these old tools, made back presumably when quality was more important than price, better than modern chisels? The answer is both yes and no. To understand what that means, you have to know how Western tool steel has evolved over time, because there have been points in history where the best tools were made. And the story of how steel developed in the Western world is both fascinating and helpful in deciding what to purchase for your shop. This is a piece of modern tool steel, and it is a marvel of technology. It has taken mankind many centuries to perfect this material, and we're still improving upon it today. Good tool steel must achieve the perfect balance between being hard enough to hold an edge, but not so hard that it's brittle. You may think the harder the steel is, the more durable the edge will be, and that's good. And it's true that softer steel wears faster than harder steel. But a very hard steel will chip and fracture, especially along the thin cutting edge of the tool. A very hard steel is also difficult and time-consuming to sharpen, because the same properties that resist wear from the wood will resist your sharpening stone as well. On the other hand, a soft steel, though easier to sharpen, may quickly dull or even deform or roll over on the edge if you ever try using it to chop hardwoods such as oak. If you ever tried doing that with a cheap chisel, you know exactly what I mean. So finding the right balance and developing a process to achieve that has been the challenge of tool makers for many generations. Iron itself is relatively soft, too soft for edge tools like chisels. But if you carefully control the level of carbon within that iron, it becomes the hard but workable material that we call carbon steel. Achieving those proper carbon levels are tricky, especially in the days before modern methods were developed. In the early times, iron ore was harvested mostly from the soil, and it was heated in a clay chimney called a bloomery. This removed the oxides and turned it into a usable metal lump called bloom iron. The bloomery was heated with a charcoal fire. Charcoal is pure carbon, and the bloom iron produced was so loaded with carbon that it was brittle and unworkable. So they would then heat it in a forge and hammer it over and over, essentially burning the carbon out to create a more workable metal, which we call wrought iron. That literally means worked iron. Wrought iron has a very low carbon content. Most of it was just burnt out, making it too soft for edge tools. A very skilled smith may be able to leave just enough carbon in the iron to make decent steel, but it was a very difficult and inconsistent process. Eventually, someone figured out that you could put carbon back into the wrought iron by placing it and some charcoal in a sealed box and heating them together for a long time in a hot furnace. The box held in the carbon-rich gases from the charcoal and concentrated them around the iron, which formed what looked like blisters on the iron surface. This is called blister steel. But most of the carbon content was on the surface. So they would draw it out into thin sheets, and they'd cut it in pieces, and they would stack them back in layers, and then they would heat and hammer that all back into a solid chunk of steel that contained inner layers of carbon throughout its thickness. This is called shear steel, and it was a great improvement in tool making. But as you can imagine, shear steel was still very inconsistent due to the uneven distribution of carbon within, especially in the old days before they discovered additives that would help the carbon gases seep deeper into the layers of iron. Shear steel was used in some tool making well into the 1800s, but perhaps the most important improvement in Western tool steel came in the 1700s, when a watchmaker who was seeking a better material for springs developed a process of using coke rather than coal to create the extreme temperatures required to melt blister steel in a sealed container called a crucible. By melting it, he was able to amalgamate the carbon and iron in a consistent way. The molten steel was then poured into molds to make ingots, which could then be forged and shaped into tools. This was called cast steel or crucible steel. And if the process was done properly, it would contain just the right amount of carbon to give it the properties needed for good tool making. But it was a long process, and tool steel remained very expensive. In fact, it wasn't uncommon to forge weld a thin strip of good steel along the cutting edge of a wrought iron tool, such as this plane iron. You can see how it grows thicker near the bottom where the steel is attached to the iron. The Bessemer process changed that. That involved blasting air into molten metal to remove impurities through oxidation. This made steel much cheaper because very large quantities could be processed at once. But now we're getting into the Industrial Revolution and the age of railroads, and blast furnaces are mostly turning out the lower quality steel that's used for railroad ties and other industrial necessities, not the small quantities of high quality steel needed for edge tools like chisels. Tool steel was still being produced by these smaller manufacturers, such as those in Sheffield, England, where they used higher quality ores and the older crucible method. To set themselves apart from the manufacturers of the lower quality steel, some began stamping cast steel on their tools as a sign of quality. Of course, the term was redundant, since blast furnaces were casting steel as well. But the term cast steel became a sign of top quality. And that may have been the peak of tool making in the Western world until modern times. It's why 19th century tools, particularly from places like Sheffield, England, and especially those marked cast steel, are so prized by woodworkers today. The quality is just undeniable. But tool making did not entirely decline after that. The story continues. Both the crucible and the Bessemer process eventually fell out of favor and have been replaced by what are called open hearth furnaces, which are able to create steel with even more consistent carbon levels. The quality is higher, but the process is much the same. Molten steel is still cast or extruded and rolled into bars like this one. This is one chisel worth of tool steel. And just like the old days, this bar is now going to be heated and forged into shape. The difference is, instead of shaping it with many hammer blows, the bar is fed into a powerful press to be squished between two molds. Then all of this excess steel is trimmed off to be recycled, and the blank looks like a chisel. But it's not ready to be sharpened yet. It has to be further hardened because steel that is soft enough to forge into shape is not hard enough to hold the type of edge woodworking requires. Hardening involves heating the tool to a specific temperature and holding it there for a specific amount of time. This alters its structure, causing the iron atoms to pull apart and allow the carbon atoms to squeeze between them, where they're locked in place by cooling or quenching the tool, traditionally by dipping it in oil or water. The result is a very dense, very hard steel. In fact, at this point, the tool is a bit too hard and too brittle. So it must undergo another process called tempering to draw back some of that hardness. This involves reheating it to a lower temperature and allowing some of those atoms to relax again. The level of heat applied during the tempering process determines exactly how hard the steel will ultimately be. Again, the goal is a tool that is hard enough to reduce edge wear, but not so hard that it's brittle. Different tools are tempered to different hardnesses for different purposes. Of course, hardening and tempering aren't modern innovations, but tool steel has continued to evolve in modern times with new alloys. This chisel, for example, contains chromium and manganese. These materials increase the steel's impact strength and edge retention, and they change the structure of the metal in a way that allows for a high-tech hardening process called isothermal hardening. It would take a long time to explain all the different modern hardening methods, including cryogenics and all the new steels and alloys and powdered metals, and I'd lose the few of you that are still watching at this point. However, it would be an interesting topic for a future video Because while the development of Western tool steel did see a peak in the 19th century, we are living in a time when a relatively inexpensive chisel like this one is made from alloys and with techniques that make it far superior to most old steel. Try one. I'll put a link below. See you next time. For a 100-year-old company, Narex sure has some secrets. Like, how can they make so many tools of such quality at such affordable prices? And why didn't I know about this company's rich history before? Narex is just full of surprises. Check them out at the link below this video.